All right, geometry, welcome back. This is going to be standard 17, the day 2 notes. We're going to start off with some new definitions for polygons here. So in standard 17, day 1, we kind of talked about quite a few things, like what the definition of a polygon was. We talked about equilateral, equiangular, reflectional symmetry, central angles, and you can take a look back at that if you'd like. But for day 2, we're going to start off and talk about what's the difference between a convex polygon and a concave polygon. So a convex polygon, which we're going to deal with or be dealing with most of the time, is just a polygon where all the diagonals are inside. Okay, and what I mean by that is if I were to draw all the diagonals for this figure, all of those diagonals are located on the inside. Okay, so let's take a look at what concave means. So concave is just going to be the opposite. It's going to be a polygon, kind of the opposite. It's going to be a polygon where one or more of the diagonals are outside. Okay, so take a look at this picture right here. So as soon as I see that there would be a diagonal, so a segment connecting a vertex to another vertex, as soon as I see that there would be one of those on the outside of the figure, that makes that concave. Yeah, there are still some that would be inside, okay, but because I have at least one of them on the outside of the figure, that's going to make that a concave figure. So let's take a second and look at the next 4 problems and just decide, are they convex or concave? So what do you guys think about these 4 figures? Take that definition and apply it here. Would they have all diagonals on the inside or some of the diagonals on the outside? And I think you're going to agree for this one, that would be convex. Looks like this would have some diagonals on the outside, so we're going to call that concave. For the third one, hold on, my pencil ran out of lead. Here we go. For the third one, I can see that there would also be a diagonal on the outside, so we're going to say that one's concave. And then for this last one here, looks like all my diagonals would be on the inside of the figure, so that would also be convex. So again, we're going to mostly be dealing with convex figures, but that was just so that you guys knew the difference between those 2 types. All right, now we're going to move on to talking about the interior angles of these figures. Now, before we get started, I just want to remind you, when we talked about triangles in an earlier standard, we actually proved what the sum of the 3 angles on the inside of a triangle added up to. And so hopefully you guys remember that for a triangle, the sum of those angles is going to be 180 degrees. Okay, we can kind of start with that, filling out this table here. You know, when we're talking about a triangle, we have 3 sides. Okay, how many triangular regions? Well, we have 1 triangle here. And what's the sum of the measures of those angles? Well, we've proven that earlier. We know that that's 180 degrees. Now we're going to actually make a connection to a worksheet that we did earlier in the year where you guys were asked in the figures to draw all the possible diagonals from one vertex in the figures. I don't know if you remember this or not, but basically you had to pick a vertex, which I'm going to pick this one right here. And from that vertex, you had to draw all the diagonals that you could draw. So I'm going to say from here, I can only draw a diagonal across over to here. So I can only draw 1 diagonal. Okay? But now I've split that 4-sided figure up into 2 figures, and each of them are triangles. So even though my quadrilateral has 4 sides, from that quadrilateral, I've now created 2 triangular regions. And what I want you guys to think about is, what are the sum of the 3 angles in this triangle? Well, it's a triangle, so that would be 180. Okay, well then what about this triangle? This triangle would also have a sum of these 3 angles of 180 degrees. And so I can think of, these angles combining to make a big angle, same thing here, along with all of these. And think about your sum here. If this is 180 and this is 180, and I add those together, then that's going to be 360 degrees. Okay, so let's do this again. So let's take a look at the third figure here. We're going to pick a vertex. From this vertex, we're going to draw all the diagonals that I can possibly draw. Looks like that's it. And then I'm going to recognize that each one of these triangular regions represents 180 degrees of interior measure, of total measure. So these three angles here add up to 180. These three here add up to 180, and so do these three here. So I count up those three, and what I'm saying is that with a pentagon which has 5 sides, that I now have 3 triangular regions, and if I add up those 3 180s, I'm going to get 540 degrees. Okay, and so we can kind of start to look at the pattern in the table here. Our side lengths go 3, 4, 5, and this has 6 sides. Okay, and I can see that there's a pattern in the number of triangular regions. That's going 1, 2, 3, and I'm going to assume this is 4 because these keep going up by 1. Okay, and then what's happening here? Every time this side length goes up by 1, I get 1 more triangular region, which means this goes up by 180 one more time. And so what I can maybe assume here is that if the side length goes from 5 to 6, the total is going to go up by 180 again. So what's 540 plus 180? It's going to be 720 degrees. So let's think about this in the general case. For an n-gon. So for an n-gon, really what we're saying here is, what if our figure had n number of sides? So we're trying to come up with a formula for this. So if I have n sides, look at the relationship between the sides and the number of triangles. And if you remember from that worksheet we did earlier, you just take the number of sides and you subtract 2. So you go n minus 2. And then what do I do with that number? Well, what's 1 times 180? What's 2 times 180? 3 times 180? 4 times 180? So whatever this number is, I'm going to multiply it by 180. So that will give us the interior sum for any figure. Now if I had a figure with 10 sides, I wouldn't have to draw it and figure out the diagonals and add up the 180s. If I have 10 sides, I would go 10 minus 2 is 8, and 8 times 180 would give me that interior sum. So at the bottom of your page here, go ahead and write down that rule here, that 180 times n minus 2. And remember, the value of n is going to be the number of sides. And that's going to find you the sum of the interior angles of a polygon. All right, let's go ahead and flip the sheet over. So we're going to take a look at the notes on the back. Okay, similar table to what we were talking about on the front page. Important distinction here, or difference, is that if you look at the top, we're now talking about regular polygons. And remember, for regular polygons, we can assume some things. We can assume that all the sides and all the angles are going to be equal. So let's take a look at just this first one here. So if I know that, so with the triangle I have 3 sides, and I know that the sum of the measures, so these 3 angles have to add up to 180, how can I find the measure of 1? Well, if these are all equal, if they are all the same number of degrees, and there's 3 of them, and I know that they add up to 180, the only value that that could be would be 60 degrees. Okay, we're going to kind of continue this with the other figures. So quadrilateral, 4 sides. You know, what's the sum of the measure if you need to? We talked about a quadrilateral. Quadrilateral sum was going to be 360. Okay, how can I find the measure of one of these angles? Well, I can go 360 divided by, well, how many are there? This is a 4-sided figure and there are 4 angles. So I've got to divide that by 4. And that tells me, and that matches up with what I see in my diagram. Each of these angles has to be 90 degrees. So think about a pentagon. So every time we add a side, how much do we add to this measure here? It goes from 180 to 360 to 540. And if I go up to hexagon, it goes up to 720. And I could do this all day. I could go 6, 7, 8, 9, and then just keep adding 180 to figure out what that sum was. But this will be 540 divided by the number of sides, 5. So the 540 divided by 5 is going to be 108 degrees. And this is going to be 720 divided by 6. 720 divided by 6 is 120 degrees. And just like on the other side, now we're going to talk about, okay, well, what if I have n sides? What if I want to come up with a formula for this? So remember, if the number of sides is n, how did I find that sum? Well, on the previous page, the rule that we came up with for the sum is right here. It's 180 times n minus 2. Okay, so if 180 times n minus 2 gives me the sum, which is the value here, then what do I do to that value? You know, what did I do to the 180? I divided it by 3. Well, that was the number of sides. What did I do to the 360? I divided it by 4. That was the number of sides. So as we can see here, what we're dividing it by is always matching up with how many sides our figure has. So your rule in terms of n would look like 180 times n minus 2 divided by the number of sides n. Okay, so think about that. We're going to write the rule here kind of officially. 180 times n minus 2 divided by n. And remember, n is the number of sides. And so how did this work? So I had 6 sides. I did 6 minus 2 was 4. 4 times 180 gave me 720. And then 720 divided by n, or the number of sides, which was 6, gave me the value of one of those angles. So just to be clear, we're talking about when we got that this angle was 60, that means that all of these are 60. When we got that this was 90, all of these are 90. When we figured out that this is 108, all 5 of these interior angles are 108. And that's specifically because we're talking about regular polygons, polygons that have all equal angles and sides. All right, so we've got one more thing to talk about. We've touched on it briefly in another set of notes, another standard, but we're going to talk about exterior angles here for a second. So the directions here say, measure each exterior angle using a protractor, and then find the sum of all the exterior angles. So what I'd like for you guys to do, if you have your protractor, to go ahead and take a break, go ahead and measure these exterior angles and see what their values are going to be. So, you know what? I think what we're going to do instead, let's take a look at this. What if I take that triangle from up top that I had, where these were all 60? Okay, we're just going to make this a little bit more simple and time saving for you guys. So in my triangle, I'm just going to say that all the angles are 60 degrees. And then for this quadrilateral, why don't we say that all of these angles are going to be 90 degrees? Okay, so let's think about this for a second. Do you remember what we call angles that are side by side that together make a line? Hopefully you remember the term linear pair. Okay, and think about what do linear pair, or what do angles that make a linear pair have to add up to? Well, if this is 60 and they have to add up to 180, then this angle would be 120. And it's going to be the same situation here with this linear pair, and then also with this linear pair. Okay, so think about those values there, and hopefully you understand that why that's 60 plus 20, that makes 180. 60 plus 20, 180, and then also these add up to 180. Now let's think about over here. Same concept. If this is 90, this will be 90. If that's 90, this will be 90. They have to add up to 180. If that's 90, this will be 90. Same thing right here. Okay, so let's, in the directions say, find the sum of all the exterior angles. So what do these exterior angles add up to? I have 3 of them, and then 120 plus 120 plus 120 is 360 degrees. Here I have 4 of them, and if I add up all 4 90s, I also get 360. So the number of sides didn't affect what the sum of those exteriors were equal to. They're going to add up to 360 no matter how many sides I have. So this last rule we're going to write down just simply says that the sum of exterior angles is always 360 degrees. Okay, so that wraps up the notes for Standard 17 Part 2. If you need to, go back and take a look at Part 1 if you want to see some of the connections between these two sets. And as always, reach out to us. Let us know if you have any follow-up questions from the notes.